here we go. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. When you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@yvcc.edu and I will respond as soon as I can. Just a reminder, Monday is accreditation day, so there will be no classes or office hour by myself on Monday. Okay, today we're going to look at section 8.2, part 2, but we'll start off with, are there any questions from section 8.2, part 1?
I had a question on, I believe 11 and 12. I don't know if you can pull it up. It's where it's like a graph.
Okay, tell you what, give me just a second here.
Go ahead. It's a 2-point question.
Yeah, okay. Hang on, and I will get it up here for you. There we go. Let's see. That. Okay. 20. Okay. And all right, this is 8.2 part 1. Yeah. So, which number did you say?
I think they were back to back. Either
12 and
11
13. It's 12 and 13. 12 and 13. Yeah. Okay. So, here we go. Determine whether the relation defines y as a function of x. Can you see my arrow moving around on the screen there?
Yes.
All right. Look at the second and the third ordered pairs. X is -3, y is 6. X is -3, y is 8. So what you've got there is you've got the same x value going to two different y values, right?
Yes.
So that's why it's not a function, which you got that one correct. Then it says, if it does not define a function, find a value of x that corresponds to more than one y value. Well, that would be that -3. -3 is the x value that corresponds to more than one y value. Okay?
Oh, okay. I see.
All righty.
Yes.
Move down the page. Okay.
Yes.
Now, determine whether the relation defines y as a function of x. No, it doesn't, because you've got an x value going to 5 different y values. So like you said, it's not a function. If it does not define a function, find a value of x that corresponds to more than one y value, and that is 70, not -70. So I'm not sure what you were thinking there, but it should be.
I don't know. I think that when I see it or hear it, like visually, I get it. And then once I get to do the homework, I get stuck.
Sure,
So, thank you for
it
clarifying.
happens. It happens. Anyway, so this would also just be 70.
All right. Thank you.
Yeah. Was that your only questions on that?
Yeah, those were the only 2 I stumbled on.
Okay. Anybody else need anything off of WebAssign while I've got it here?
Nope.
Okay. Well, then I will get rid of that and we'll go back to this screen. And we ready to go on to the second part of 8.2?
Yes.
Okay. So I'm going to start off actually with some graphing. So let me do this. We're going to close this up and open this up. Hopefully things will work well today. You just never know. Okay. So let's say we'll put that here and this right there. Let's say we've got the function f of x equals 2/3 x minus 2. Now, this is a function. We're using function notation, but it's the same graph as if we graphed y equals 2/3 x minus 2. So basically, this function is in slope-intercept form. y equals mx plus b. So the slope of the line is 2/3 and the y-intercept is -2. Everybody understand what I'm doing there?
Yes.
Okay. So I'm going to start at -2. I'm going to go up 2 and over 3, up 2 and over 3, according to the slope. And then I'm going to draw the line. And I'll put some arrows on the ends of it. And I'll move this out of the way so that you can see it. So there is the graph of f of x equals 2/3 x minus 2. Does anybody want me to go back and find the same graph, but using ordered pairs instead of slope-intercept form?
I don't think so.
You're
Thank
good
you.
with that? Okay.
Yeah.
Let's go to a new page and we'll make a new graph. I'm not marking the scale on here for the sake of time, but each square is going to be 1 unit. Okay. And let's take a look at this. F of x equals -x. That's also in slope-intercept form. What's the slope?
1.
Careful.
-1.
-1. What's the y-intercept?
Oh, 1.
No.
No.
Would it be 0?
0. Yeah. So f of x equals -x is like -1 times x plus 0. Okay. There's no constant, so your y-intercept is 0, and your coefficient is an implied -1. So the slope is -1, the y-intercept is 0, so it's going to go through the origin and go down 1 over 1. You okay with that?
Yeah.
And so the graph would look like that. Okay, let's take a look at another one. We've got f of x equals 2. Well, that's the same thing as y equals 2. When you've got an equation that's just got one variable in it, like y equals a number, do you remember what that looks like?
Is it one is a straight line up and down and one is a horizontal or vertical and horizontal?
Which one is this?
Ooh,
Think about it. Y equals 2. So every point on that line has to have the same y value. So would that be vertical or horizontal?
horizontal.
Correct. Good job. And I suppose if you wanted to write this in slope-intercept form, it'd be f of x equals 0x plus 2. So the slope is 0. The slope of a horizontal line is 0. And the y-intercept, whoops, the y-intercept is 2. So horizontal line passing through y equals 2. We okay with that? Well,
Yes.
we'll see. All right. Now I'm going to go back to my other board. And we'll look at this. And let's see here. Make sure that everybody's seeing. So you see my whiteboard there? Yes? Maybe?
Yes. Yes.
All right. We're gonna if you took Math 85 from YBC, you've done the things we're going to do next back in chapter 3, which was the graphing chapter, but we weren't dealing with function notation. But if you didn't do 85 and it's been a long time, as we go along, if you need some background more than what I'm giving, say so and I'll try and fill in the gaps, okay? All right. It says, write an equation for a linear function whose graph has the given characteristics. it has a slope of 5 and a y-intercept of 0, -3. Recall that a y-intercept has an x-coordinate of 0. An x-intercept has a y-coordinate of 0. So this y-intercept has an x-coordinate of 0. Now, we want to come up with a function, and we're going to write it in slope-intercept form. So when we get done, it's going to look like f of x equals mx plus b. But we're going to find the slope, and we're going to find the y-intercept. Now, for this problem, they give us both pieces of information. The slope is 5, and the y-intercept is -3. Recall we use the letter m to stand for slope and the letter b to stand for the y value of the y-intercept. So now using y equals mx plus b, the 5 goes in the place of m, y equals 5x, and the -3 goes in the place of b, so y equals 5x minus 3. All that's done is to use function notation. So f of x equals 5x minus 3 would be the final answer. Any questions about that?
No.
Okay.
No.
Take a look at another example. Here we have an equation of a line, a function, that passes through the point 1, 7 and -2, 1. Again, I want my final answer, f of x equals mx plus b, so I need to find m and b. In this case, I have neither one, but I have 2 ordered pairs, 2 points on the line. So using the slope formula, which is m equals y subscript 2 minus y subscript 1 over x subscript 2 minus x subscript 1. I'm going to call the first point, point 1, and the second point, point 2. So now this first coordinate is x sub 1, and this is y sub 1, and this is x sub 2, y sub 2. Do you remember doing this, finding a slope from 2 points? We'll find out here. So y sub 2 is 1 minus y sub 1, which is 7, over x sub 2, which is -2, minus x sub 1, which is 1. Any questions? All right. 1 minus 7 is -6. -2 minus 1 more would be -3. -6 divided by -3 could be reduced down to 2, so the slope is 2. So now, using y equals mx plus b, since the slope is 2, I have y equals 2x plus b. So I've found the slope, but I haven't found the y-intercept yet. And neither of those given points are the y-intercept. I know that because if it was a y-intercept, the x value would have to be 0. But I can use either one of those points in this way. I'm going to go ahead and use the first point. X is 1, so that's going to go right here. Y is 7, that's going to go right there. So now I've got 7 equals 2 times 1 plus b. Any questions? All right, 7 equals 2 plus b. Subtract 2, 5 equals b. I already have the slope. Now I have the y-intercept. So y equals 2x plus 5. But using function notation, f of x equals 2x plus 5. Now, a question you might have is, What if we use this point instead? If we used that point instead, we would still get b equals 5. Do you want me to show you and prove that to you, or are you good to go?
I'm good.
All righty. You'll just believe anything I say today? No.
Yes.
All right. We okay with this problem? Any questions?
I'm okay.
All right. Now we want to come up with a function described by a graph that passes through the point 3, 0 and is parallel to the graph of g of x equals -2/3 x minus 4. Okay. Parallel lines have the same slope. So if line 1 is parallel to line 2, the slope of line 1 equals the slope of line 2. We could say if line 1 is parallel to line 2, the slope of line 1 equals the slope of line 2. All right. Likewise, if the slope of line 1 equals the slope of line 2, line 1 is parallel to line 2. So that statement goes both directions. Any questions about that? All right. Since the line we're trying to find is parallel to the original line, we need the slope of the original of g of x. What is the slope of this function?
-2/3.
-2/3. So that's the slope we're going to use. So we're going to use this slope and this point, this new point that's on the new line we're going to create. So all we used that original g of x function for was to get the slope. Since the lines are parallel, we're going to use that same slope. So now I've got y equals mx plus b. M goes there. Y equals -2/3 x plus b. Just like I did previously, I can take this ordered pair and let x equal 3 and y equals 0. So now I've got 0 equals -2/3 times 3 plus b. Okay. 0 equals -2 plus b. Add 2 to both sides. B equals 2. So I've got the slope of the new line, the y-intercept of the new line. So we've got, let's see if I can stick this in here, y equals -2/3 x plus 2, or f of x equals -2/3 x plus 2. We good to go with that one?
Yes.
Yes.
Any questions? No? Okay. Let's see here. Now we're going to come up with the function that passes through the point 1, 2 and is perpendicular to the graph of g of x equals -x/6 plus 1. All right, now parallel lines have the same slopes. Perpendicular lines do not. When lines are perpendicular, the slopes are negative reciprocals of each other. So let's say that line 1 is perpendicular to line 2. If slope 1 is 2/3, slope 2 would be -3/2. So when they're perpendicular, you change the sign and you take the reciprocal, both of those things. Likewise, if two lines have slopes that are negative reciprocals, the two lines are perpendicular. That is to say, they meet at a right or a 90-degree angle. Okay? Now, let's take our g of x. What is the slope of g of x?
Would it be negative 1/6?
Correct, negative 1/6. So what would the slope that's perpendicular be?
+6.
Yeah, positive 6/1 or just 6. So now we're going to use the slope that's the negative reciprocal of the original, along with a point on the new line. Is everybody okay where we came up with a slope equals 6? Or actually, you came up with that. Okay, so y equals mx plus b. 6 goes in the place of m. Y equals 6x plus b. X is going to be 1. Y is going to be 2. So 2 equals 6 times 1 plus b. 2 equals 6 plus b. Subtract 6. Negative 4 equals b. So I know the slope is 6. The y-intercept is negative 4. So y equals 6x minus 4. But as a function, f of x equals 6x minus 4. So there you have that function.
Our final answer would be the function instead of y.
Yes, because it says write each equation for a linear function. So because they're telling you it's linear, excuse me, that they're telling you it's a function, they want function notation.
Okay, thank you.
And you'll probably see that in WebAssign. It'll say something to that effect. Okay. We now want the equation of a line that is horizontal and passes through the point -8, 12. Now, earlier today, when I was graphing lines, one of the lines I graphed was f of x equals 2. And I said that was like y equals 2. And I asked one of you, or one of you told me about how a horizontal line, y equals a constant. We never talked much about the vertical line. You mentioned it, but a vertical line would be x equals a constant. So a horizontal line would be y equals some number. Well, if this graph contains the point -8, 12, and y equals 12, that 12 would, that 12 would have to be that some number. So it would be y equals 12, but as a function, f of x equals 12. So a horizontal line passing through the point -8, 12 would be f of x equals 12. If we were to do it graphically, we'd come over here to -8 and go up here to 12, and we'd have this point, and then we draw a horizontal line through it, and then be like, oh, that's a horizontal line, so it's y equals 12, etc., etc. Okay with that?
Yes.
Yes.
So let me quickly review some things. To find a y-intercept, set x equal to 0. To find an x-intercept, set y equal to 0. The slope formula is m equals y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Parallel lines have the same slope. Two lines with the same slope are parallel. Perpendicular lines have slopes that are negative reciprocals. If two lines have slopes that are negative reciprocals, the lines are perpendicular. Y equals mx plus b. In that form, m is the slope and b is the y-intercept. Let's see. Oh, an equation of a line y equals a constant is a horizontal line. An equation of a line x equals a constant is a vertical line. And two more pieces of information. The slope of a horizontal line is 0 because you're going up or down 0 as you go over to the right, and 0 divided by a non-zero number is 0. The slope of a vertical line is undefined because you're going up or down divided by zero run. And if you take a non-zero number divided by zero, it's undefined. Okay, I just rattle off a whole bunch of information there. There's 10 fun facts for graphing. If you want to study them more, they all came out of chapter 3. Or if you have other questions that you want me to address, let me know, and I will. What we're going to do now, we're going to go on and look at an application problem. And let's go back earlier. We took 2 ordered pairs, and from that we came up with a function. We're going to look at an application problem, or a story problem, if you will, where we're going to extract 2 ordered pairs from the reading and use this idea here to come up with a function. Okay, so here we go. Let me put on my glasses so I can see here. It says, nurses, the demand for full-time registered nurses in the United States can be modeled by a linear function. So f of x equals mx plus b, or g of x equals mx plus b, something like that. In 2005, so in the year 2005, approximately 2,175,500 nurses were needed. Don't worry about frantically scribbling down those numbers. I'm going to put them all down here eventually. By the year 2015, that number is expected to increase to about 2,586,500. Okay. Now, obviously, this problem is old. We could go back and see if it really happened. But anyway, part A says this: let T be the number of years after 2000, and N be the number of full-time registered nurses needed in the US. So T equals time after 2000, and N equals number of full-time nurses needed in the US. Okay. Write a linear function N of T to model the demand for nurses. N of T. Now, T is time in years after the year 2000. So in the year 2000, T would be 0. In the year 2003, T would equal 3. In the year 2020, T would equal 20. Okay. N is the number of full-time nurses. Okay. The fact that they want the function written in terms of N of T, that tells us that T, which is on the inside, is the input. N, which is on the outside, is the output. So as time goes on, the number of nurses change. It's not the other way around. The number of nurses changing doesn't make time go on. Time goes on, and as that happens, the number of nurses change, okay? T is the input, N of T is the output. So our ordered pairs are going to be in the form T, N of T. Any questions? Now let's go back and read the problem again. The demand for full-time registered nurses in the United States can be modeled by a linear function. So it's going to be N of T equals MT plus B. M is the slope, B is the y-intercept, or technically the n-intercept, if you will. In 2005, okay, so what time is it in 2005? What would T stand for?
5.
5. In 2005, approximately 2,175,500 nurses were needed. 2,175,500. So 5 is the input, 2,175,500 is the output. Time, nurses. Okay? By the year 2015, oh, what time is it now?
15.
The number of nurses, number is expected to increase to about 2,586,500. Okay. So there are two ordered pairs. Anybody have issues as to where we came up with them? So now we're going to use the same technique we used earlier on given two ordered pairs, find the function. We're going to come up with a slope. So the slope is going to be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Now, one could argue that it should be n of t sub 2 minus n of 1 sub, or n of t sub 1 over t sub 2 minus t sub 1. But let's just leave it in terms of x and y, and then we'll write it in terms of n and t when we're at the end, okay? I think that makes it a little easier to follow. So I've got y sub 2 minus, oops, I wrote that wrong, didn't I? Hang on. Okay. This is 0.2. This is 0.1. So y sub 2, 2,586,500 minus y sub 1, 2,175,500 over 15 minus 5. Okay, well, it's calculator time. Let's see here. 2,586,500 minus 2,175,500, and I'm coming up with 411,000. 15 minus 5 is 10, so that's going to reduce down to 41,100 over 1. So the slope is 41,100. Any questions about that? So we've got our slope. So now using y equals mx plus b, the slope's going to go in there. I'm going to get y equals 41,100x plus b. Technically, we're using t and n of t, but I'm going to think of them in terms of x and y. So x is going to go there, and y is going to go there. So I'm going to get 2,175,500 equals 41,100 times 5 plus b. 2,175,500 equals, let's see, if we take 41,100 times 5, we get 205,500 plus b. Okay, I'm going to take that and copy it on the next page. 2,175,500. Let's see, equals 205,500. 205,500 plus b. Did I get that copied correctly? I think so. I will subtract 205,500. Wait, is that right? Yeah, it is. Okay. 205,500. I was wondering if I didn't have enough zeros there or something. So let's see here. 21750, oops, 500 minus 205,500, 197,000 equals b. All right. So from the previous page, the slope was 41,100. So y equals 41,100x plus 1,970,000. But it's actually n of t equals 41,100t plus 1,970,000. So there is the correct function using the correct letters. Okay. There's a follow-up question, but before we look at that, I want to ask you some questions of my own. But before I do that, do you have any questions about what happened so far?
No.
Okay. Now, this number is the slope graphically, but what does it represent in terms of the real situation? What is that telling us?
Does it mean that to start off with, I don't know, is it 1,970,000? I don't know how to pronounce it correctly. Is that how many they started off with?
Okay, now hang on. I was asking about this, but you're telling me about that, and that's fine. So this, to start off with, when?
That's the first year.
Which is when?
2000, right?
2000.
Bingo. So yeah, so this is the number of nurses that there were in the year 2000. But now back to this. What is this telling us?
That's how many it increases by year.
Exactly. That's the rate of change. So based on this function, the number of nurses increases, or the number of nurses needed increases at a rate of 41,100 per year. Okay. So in the year 2000, we've got this many nurses and they're increasing at a rate, the need for them is increasing at a rate of 41,100. I think it was the need. Yeah, the need. Okay. Now, follow-up question. It says, use your answer in part A to predict the number of full-time registered nurses that will be needed in 2025. Wow, I'll bet that's changed because of this virus, but who knew back then? All right. Use your answer in part A to predict the number of full-time registered nurses that will be needed in 2025 if the trend continues. Now, here's what I want you to do. I want you to use short, concise function language to tell me what they want us to find. And if you say more than about 3 or 4 words, you're saying too much. They want to know that, they're asking about the number of nurses in 2025. So what do they want us to find? Nobody wants to try after that big long.
I don't want to try after the 3 or 4 words.
All right.
But they want you to input 25 word.
Okay,
T.
stop. You're right. They want us to input 25. So how would you say that? Find what?
T.
N of 25.
N of 25. There you go. Okay, we know what T is. T is the 25 because it's the year 2025. So we're talking 25 years after 2000. So they want us to find N of 25. Does that make sense?
Yes.
So,
Yeah.
so the long story is they want to know how many nurses there are 25 years after the year 2000, blah, blah, blah. The short one is find N of 25. So there's your concise function language. All right. So that's going to be 41,100 times 25 plus 1,970,000. So we go to our handy dandy calculator and we've got 41100 times 25 plus 1970000. And let's see here. I come up with 2,997,500. So that would be the number of nurses that they are estimating would be required in the year 2025. Okay. Or we could say N of 25 equals 2,997,500, which means in the year 2025, that many nurses, registered nurses, are needed. You okay with that?
Yes.
All right. Oh, let's see here. Trying to look at this. I think that's all I'm going to do with you today. It's hard for me. There's pictures I could, well, you know what? I'll do one more and just don't laugh at my lovely drawings. or go ahead and laugh if you want. Okay, we've got a storage tank. Let's see here. And this is why I'm not teaching art class. And we know that this distance is 12 feet. And the radius, so this end cap is kind of a dome shape. The radius, we're going to call R. So it's 12 feet from here to here, and the radius of this end cap is R. It says the volume, V of R, of the gasoline storage tank in cubic feet is given by the polynomial function V of R equals 4.2 R cubed plus 37.7 R squared, where R is the radius in feet of the cylindrical part of the tank. What is the capacity of the tank if its radius is 4 feet? So now, realistically, you don't even need the drawing. It's just kind of helping you see things along there. But what they're saying is this function describes the volume of that tank. R stands for the radius. We're told specifically that R is 4 feet. So using concise function language, tell me what they want us to find.
V of 4.
Bingo. Good job. You are that much closer to becoming a full-fledged math nerd, which of course is my goal, to turn everyone into a math nerd. You're getting closer. Good job. So 4.2 times 4 cubed plus 37.7 times 4 squared. And let's see, in the calculator, what do I get? 4.2 times 4 cubed plus 37.7 times 4 squared. And I'm getting 872, and that would be cubic feet because it's three-dimensional. All right? You okay with that?
Yes.
Yes.
All righty. Well, we're going to call that quits for the day. I'm going to stop the recording.